Hi, I'm Robert E. Stewart, but most people in fastener engineering and manufacturing know me as Stu. I am the Vice President of Design Engineering for AlphaUSA. I've been in the fastener and metal stamping industries for a long time now, starting out making fasteners for brake cable control systems, electronics component metal stampings, brackets, things like that. I feel I have the most wonderful job of all the jobs here at AlphaUSA, and that's because I get to imagine what the future of manufacturing is going to look like for the automotive industry of the future. I've been at AlphaUSA for 21 years now. When I came here, the decision was to change the approach to serving their customers. That change in approach led to a new methodology for reaching out to new customers and to better supply the needs of our current existing customers. That approach involved getting in earlier on in the engineering and design process and working with their engineering groups on vehicles that are 2, 3, 5, and even 10 years out in the production schedule, and getting our best ideas and our best products on those vehicles in order to help with ergonomic assembly, light weighting, being very mindful of cost controls and restrictions. In fact, we have had a good deal of luck, not just with existing customers, but with new customers by reaching out to them and not just saying, trust us, we can help you, let us quote on your products, but rather we understand you get a lot of people in your offices that are looking for an opportunity to quote your work. What we'd like to do is give you an opportunity to show the value of doing business with AlphaUSA. And we do that by offering that we will take their most broken and damaged and troublesome applications, and at no cost to them whatsoever, we will take them within our engineering group and we will create solutions for those challenges, be it in assembly, in product ergonomics, cost problems, parts are too expensive and you need cost reductions in order to maintain the viability of your platforms. We can do that. So by participating in those value-added, value engineering events, we've come up with just scores and scores of opportunities to help new customers and old customers. It's a way of building credibility with these new customers and assuring that with our existing customers that they're keeping us on as a supplier to them is one of the best decisions they could make for the value that we bring to them. With regard to patents, we've been fortunate enough to have been invited into our customers' family of suppliers and contributors to their new vehicles. One of those invitations led us to participate in the General Motors EV1 design. And I was brought in very early in that design process because they were making the vehicle frame, the front assembly actually of the vehicle frame out of extruded aluminum. And it became problematic with all the cutaways for fastening and joining that were necessary in that aluminum structure, that it was weakened significantly. And I was brought in order to reevaluate the fastening strategy for that vehicle, and it ended up being completely re-engineered extruded structure design that I came up with. And as a result of that, that became my first patent jointly with the good engineers at General Motors. And that expertise in working with the extreme light weighting needs in order to provide range on that vehicle, as well as the needs for providing very robust support on a very lightweight and somewhat new manufacturing material, aluminum for frames. It was pretty forward thinking, and as a result of that, a patent was granted, and that was the first of what became many. When you do good work and you help your customers, word gets around within the corridors. These are big companies with lots of engineers, but it really is a small and tight family of people who are knowledgeable and who know whom they can count on when they need some really serious engineering support. And it was that earned relationship that got us continuing calls for further design support and further help. Ford Motor Company, C-Max, plug-in hybrid electric, we received a patent for a redesign of their brake pedal assembly that resulted in a significant cost savings over the cast components that were used, as well as extreme savings in weight on that vehicle. We have a number of patents jointly with our customers. We are a fastener provider, and we've engineered some very interesting fasteners. We come up with a design that fits what we think is a missing opportunity in the market that's already out there. Thinking of clip-on U-nut type products. We were able to find a way of manufacturing at very high rates of speed a cold-headed fastener assembly that clips in place and stays securely in place. But it's not just designing a product. In some cases, the equipment that manufactures the product doesn't exist. So we actually had to design the machinery that manufacture it as well. And then we put it to our best employees in the tool and die department, in the tool and die maintenance department, in the machine maintenance department. And we asked them to take a look at it and tear the idea apart. Is it too complicated? Is there an area on the machine that could be simplified if we were to change the design slightly so that we could contain the costs of implementation of the tooling to manufacture the parts and the cost of the overall machinery, but also make sure that the part isn't over-engineered and therefore too expensive. So it was through that effort that we were able to come up with the first single part that seemed to serve that need for our customers very well. And from that single part, the other challenge was working with the internal group to determine that we want this to be scalable. We want to be able to manufacture this part from an M4 all the way up to an M20 size, and we want it to function just as properly, just as ergonomically, and just as robustly across that full line of sizes. And with relentless persistence and pursuit of that goal, we were able to come up with a whole series of clip-on fasteners that have now become the industry standard, the published industry standard. That's where we're at today, but as you know, my responsibility is tomorrow. What we're working on today is further evolution of our fastening systems for the vehicles of tomorrow. Why would we employ barrier films? Why would we employ spray-on barrier coatings? And when we could reimagine how we encapsulate and how we manufacture our fastening systems. We were originally looking at steel reinforcement ribs that are buried deep within nylon. We're also looking at fasteners embedded into nylon over-molded products. And then as we continued to evolve and to imagine what tomorrow would look like, the question became even more fundamental. Why even use steel? We've started experimenting with and working on a line of products that are going to be out there a few years, but you will see them. And they are using carbon fiber reinforced nylon. And these are going to be manufactured in production at the higher volumes that are able to support the manufacture of these new next generation of lightweight vehicles and autonomous vehicles. People sometimes ask me, gee, Stu, that's a pretty cool idea you come up with. How long did it take you to do that? And I usually reply, somewhere around 45 years, because it's accumulation of all of the projects that we've worked on and all of our cumulative experience with all the engineers and all of the technicians that we have here at Alpha. It's that accumulation of knowledge that is really the thing that we bring to bear on what we do. And the fact that we've generated families of products, so for more and more what we're able to do is by having already a family of products as an offering for a particular problem, we can offer these pieces at no tooling charge, available immediately to solve those problems. Longer term, however, we've set upon ourselves a challenge. It's easy to have a quick response to the customer if you already have something designed and sitting in a box ready to solve their problem. But there are an awful lot of problems we can help that way and solve that way, but there's an equal number that require a good deal of effort and thought. We have challenged ourselves from the beginning, from the 21 years ago that I started here, that within 48 hours of a communication from a customer that they have a problem that they need our assistance with, within 48 hours, we will provide them with a 2D drawing, fully dimensioned, so that they have something that they can share with some of the other groups in their company to understand. We also give them a 3D model in step format, or we use NX here. We can do it as a PRT file, and we can communicate that way with models which they can drop into their structure and validate quickly. And in addition, in that 48 hours, we give them a 3D printed example or two to hold in their hand, not just of the part, but sometimes in a portion of or the entirety of the structure that it's meant to interact with. And by doing that, we have allowed the customers to be able to move forward much faster with design. It used to take a good deal more time, and that if we came up with an idea from a 2D print, someone would have to take the leap of faith, move it through their organization, and get a purchase order for a steel facsimile of that, a prototype part to be made, or several to be made, for them to see them. And it would take, sometimes 6-8 weeks to get our hands on that and share it with the customer. That's all gone now with 3D printing and direct metal laser sintering, which we're evolving towards as well. The 3D printing is working with plastics and carbon fiber reinforced plastics, but the direct metal laser sintering works with powdered metal, and basically through laser is able to melt that powdered metal into the precise shape of the product that you have in mind. The difference being the product you finish in direct metal laser sintering is pretty close to exactly what you'd expect. So you can clamp it up, you can tighten it down, you may even be able to get some limited durability evaluations done on that. So we're evolving in all those regards, but that key focus on getting the right answer to the customer in 48 hours, we've held ourselves to that so long now, and we've learned to rely on one another for the ideas and the double checks that we need to be confident that we're not just shoveling an idea out quickly, but it is the correct idea for the application and the customer's need. As I'd mentioned earlier, a lot of the products that we've designed, we, even though it seems like it's a conversation with an individual engineer at a customer's offices with a very unique problem unto themselves, we have an advantage. First of all, we maintain the strictest of confidentialities. We don't cross-pollinate any of the conversations between our customers. But we do come up with our own solutions, like the clip-on fasteners, for example, where the part itself is, as we mentioned, is so scalable that we can make anything out of it from an M4 up to an M20. What happens is we look at the application that the individual engineer is giving us, and then we imagine a solution to his particular problem, but we say to ourselves in that process, if he's having this problem, there surely must be engineers in his own organization and in other organizations that would benefit to the solution that we have here. They would benefit immensely from knowing that we've anticipated their need and we came up with a very unique solution to that problem. And we do that an awful lot. And what ends up happening is that word of mouth within the engineering groups at all of our customers. we solve a problem. We save the launch of a vehicle, the timing to the launch of a vehicle, because of our coming in at the 11th hour with something very unique and executed flawlessly and very quickly within our manufacturing organization. That gives us the opportunity to share those ideas and imagine those ideas in other customers' applications. So there's an awful lot of that goes on, mostly from our own internal discipline, that if we come up with something, there must be a need for it beyond the conversation we're having right here. And we demonstrate that every day, that we're thinking beyond this part. We're thinking of a whole new family of products that would be helpful. One of the things that is the most valuable to us as an engineering group in anticipating our customers' needs is the support and encouragement of our ownership family and the president and CEO and the board members of our company. And the reason for that is they insist that every single year we get together off-site as a management group, and we have one assignment, and that is every product we currently manufacture is about to go obsolete because of an evolution and a revolution in technologies. What are we going to be doing? What are we going to do to keep ourselves relevant 3 years out, 5 years out, and 10 years out from today? Imagine that all the products and all the good work we've done is no longer saleable. What are those products for tomorrow? And that's a pretty tough challenge. And it just shows the commitment to a relentless pursuit of excellence and an anticipation of the market and where it's going and what do we need to do to stay relevant. And we're working on that sort of thing right now in the combination of products. And I mentioned earlier about manufacturing using magnesium. One of the things you find by talking to people is that wherever they put a fastener on a magnesium structure, like an engine cradle or something like that, at the connections they put a sacrificial piece of aluminum down, 6061 aluminum T6. That's for the purpose of, if there's going to be galvanic corrosion between metal and magnesium structure, that they're going to let that aluminum piece be the sacrificial piece and protect that very expensive, very detailed magnesium piece and the fastener assembly itself for the integrity of the vehicle. And they also, in addition to that, they put a barrier film on. So one of the imagine this for tomorrow came out to be, we're going to take a certain family of our products and a certain evolution of our products, and we're going to manufacture incorporating 6061 T6 aluminum and a barrier film onto the part assembled off the machine at a very high rate of speed. So no longer will the customer need to have a secondary piece of sacrificial aluminum. No longer will the customer have to have a barrier film. Everything will be incorporated in the fastener. Ergonomically, they can snap it in place as easily as they always have, and they need not worry anymore about the sacrificial nature of the relationship between metals and magnesium. That's one of the things that has come out of one of those planning sessions for what is tomorrow's products. I'm very fortunate today that I get to talk to you a little bit about the skills and the expertise and the products of AlphaUSA. This company is so deep with talent throughout their tool and die making staff, throughout their quality engineering and validation expertise, their manufacturing expertise, the high-speed interchange of tools from one job to another, and the commitment of excellence that each of our operators take each time they manufacture a product and place it in a container on behalf of our customers. They take that responsibility very, very seriously. There's a lot more commitment to the betterment of our customers than I can express here in talking to you directly. I implore you to come out, take a tour of our facility, and meet some of these people and let them tell you their stories and what their contribution is to this story that is AlphaUSA. you will definitely walk away impressed. Thank you.